This video is on sample problems on how to use the four equations that you all learned in the first two videos, the velocity and the acceleration video. The only thing I'm going to do here is I'm going to write the equations differently. I'm going to write them in the basic form that you would see them on the AP formula chart. And so there are four. The first one is V is equal to the change in the position over time, delta x over t. The second one is V, final velocity, is equal to V naught, the initial velocity, plus a times the time. The third one is the change in the position is equal to the initial velocity times the time, plus 1/2 acceleration times the time squared. And last, velocity squared is equal to the initial velocity squared plus 2a times the change in the position. The only thing that's different is the subscripts. Instead of I for initial and F for final, we use this little circle called naught for initial, and the one without the subscript is always the final. So I'm going to use these forms of the equation, and over time you'll get used to it. So let's take a look at the first set of questions, and really the only thing I want you to get out of this video is the format in which the questions are done. All the information that I need to see on your UT homework and on your tests in order to get full credit. So that's what this video is really about. So the format is what I call the guess method, which is G, U, E, S, S. And each letter stands for something different. The G stands for listing the given information in the question. So let's take this one for example. I have an athlete who sprints 50 meters in 8 seconds. He then stops and walks back to the starting position in 40 seconds. And so we have a three-part question. And notice it's not the question that I'm really trying to focus on, it's the format in which I do the question. I always do the same 5 steps, 1, 2, 3, 4, 5. I always do the same 5 steps with each question. So the first question is what is the average sprint velocity? So I list my givens. The sprint velocity, I have a displacement of 50 meters. Make sure you list the variable and give the value for that variable. I have a time of 8 seconds, and I want to know the sprint velocity, V. So there's the G, the given information. Here is the unknown, the velocity. And now I have to do the equation. Well, the version of the equation that I want to see is the version that reflects the unknown that you're looking for. This question is pretty simple because I am looking for velocity and you don't have to change the equation around. The equation is V is the displacement over time. So that's the E. The S is the substitution, putting the right numbers in the right locations. So I have 50 divided by 8, and the last S is the solution with the proper unit. And that answer is 6.25 meters per second. So that would be A. For B, what is the walking velocity? Again, displacement because he's walking back, so it's the same 50 meters. The time, though, is 40 seconds, and I want to know the walking velocity. So there's the given information. Here's the unknown. Here's the equation. V is delta x over t, which is 50 over 40, or 1.25 meters per second. And lastly is C. What is the velocity for what is the average velocity for the complete round trip? Be careful. The definition of velocity is displacement over time, your change in the position over time. Well, the change in the position is 0 because he starts at the beginning and he ends in the same spot, so he doesn't change his position in any way. The time is 48 seconds. 8 seconds out, 40 seconds back. So V is the displacement over time, or 0 over 48, or 0 meters per second. It is confusing, but that is the way it is. So each time I did this same format, GUESS, given information, unknown variable, what I'm looking for, the equation that reflects what I'm looking for, substitution, and your solution with the unit. Let's just go ahead and do this one real quick. What would the x versus t velocity look like? In the sketch, I have my displacement and I have my time. Well, it looks like he's probably going to speed up, so I would have a curve, and then he's going to walk back. So I'm going to get a kind of, well, I won't have him slow down. I'll just have him walk back. So something like that. So here's him running out, and here he is returning back. So that's displacement versus time graph. Let's take a look at this other question here. This is acceleration. We're going to use some acceleration equations. The reason why I want you to list the given, because the common question is, what equation do I choose? Well, you don't know which equation you're going to choose until you know what variables you have, which is why you always list the information, because you want to choose the equation that has all the variables you're looking, or all the variables you have, plus the one you're looking for. So that's why you have to list your given information. Well, this is an interesting scenario because three things happen. There's 3 windows of time, and you have to be clear that you understand everything that's happening in a problem before you tackle the problem. So if I read the question, it says a train is moving in a straight line with an initial velocity of 0.5 meter per second. It accelerates for 2 seconds, or 2 meters per second for 2 seconds. Then he coasts at 0 acceleration for 3 seconds. And then he accelerates negative 1.5 meters per second for 1 second. So 3 things have happened. First, he accelerates in a positive direction, then there's no acceleration, and then lastly, negative acceleration. So now that you know what the question is asking, we can start answering these questions. What is the final velocity of the train? Is A. It wants to know, after all these 3 events, what is the final velocity? Well, we have to break these 3 events down separately. So let's take a look at the first event. The first event is an initial velocity and an acceleration for 2 seconds. So the first event, I'm going to say my V0 is 0.5 meters per second. My A, acceleration, is 2 meters per second squared. My T is 2 seconds. So if I can figure out how fast he's going after this 2 seconds, that'll put me a step closer to the end of the problem. So it's the final velocity at the end of this window. So there's the givens, here's the unknown. The equation is V is equal to V0 plus AT, because here's everything I have plus the one thing I'm looking for. So that's the equation that I choose. Then I plug in the information. 0.5 plus 2 times 2 seconds gives me 4.5 meters per second. So this is how fast he's going after the first window of time. Well, the second window of time, there is no acceleration. So at the end of the second window of time, nothing has changed. He's still going 4.5 meters per second. The third window of time, now I'm starting to slow down. I'm going to change my velocity. So I'm going to list some information here. Let me scratch these out so I can use this space. So in the third window of time, my initial velocity is 4.5 meters per second. My A is negative 1.5 meters per second squared, and I'm going to accelerate in a negative direction for 1 second. So I can say my final velocity is 4.5 plus 1.5 times 1, negative 1.5 times 1. And when all is said and done, the answer is 3 meters per second. Now I did forget a step. The step I forgot, actually 2. I need to know the final velocity, Here's my unknown, and I need my equation. V is equal to V naught plus AT. We should always write that first before we proceed in this step. So I did forget some. I'm tired and I want to go home. So that's what's happening. So there is A. B is what is the average acceleration of the train? Average, meaning I'm going to look at the whole event as one window of time, and I want to know what the average, what's going on in there. So average velocity is equal to the change in the velocity over the time. So V minus V naught over T. What I did was I took this equation and rearranged it to solve for the variable that I'm looking for, A. This is the version of the equation I need. And since this is the third part of this other question and none of this information has changed, then I don't have to list it over again. Well, the final velocity is 3 meters per second. The initial velocity is 0.5 meters per second, and the entire time is 3 plus 1 plus 2, so 6 seconds. And the answer is 0.42 meters per second squared. And it's just really the format. That's all I want you to get used to. And what you have to remember is if you list your givens and you state your unknown, that will lead you to the equation you use. And let's go ahead and finish up this final part, I guess. The graph. We have some acceleration. So this is a position versus time graph. X versus t. So I'm going to accelerate. And then I'm going to coast, straight line. And then I'm going to slow down. So I'm going to curve down a little bit, slow down. And then I'm going to have a flatter line because it's a slower velocity. And so that is what this position versus time would look like. Speeding up, constant velocity, slowing down. Well, I hope this helps. And of course this might seem confusing, but you'll start to get it once you get into your UT homework and you practice it over and over again. So I will see y'all in class.